All right, Algebra 2, welcome back. We are doing notes number 3 today. We've been talking about arithmetic and geometric sequences. And we've got one more quick little thing to do today. And then tomorrow you'll actually be given a quick little kind of check-in just to make sure everybody's got the basics down on all this stuff. So you won't see this stuff on the quick check tomorrow, I don't think. Maybe something easy. But up next, arithmetic and geometric means. So just at the top of the notes today, number 3, I kind of wrote again our different sequences and the formulas that we've gone through. So we've got arithmetic sequences with the first term A1, common difference is D, and then we've got that formula that gives us all of our terms for an arithmetic sequence. So arithmetic, we've got a common difference, and there's our formula to generate terms. For a geometric sequence, right, we've got a common ratio, so we're multiplying every time, and there's our formula to generate terms. So arithmetic and geometric sequences. Okay, so last quick little thing that we can use sequences for are what we call arithmetic and geometric means. Now that word mean, you've talked about that before, and this first part should be pretty simple. You're going to know what this means. So the terms between two given terms of an arithmetic sequence are called the arithmetic means of those given terms. So for instance, if I make a sequence that's arithmetic, so we'll keep it simple. Let's do 3, 5, 7, 9, 11, right? That is an arithmetic sequence because to get the next term in the sequence, I'm just adding 2 every time. 3 plus 2 is 5, 5 plus 2 is 7, and so on, right? So if I look at the first and last term, right, so 3 and 11, all of the terms in between the 3 and the 11 are arithmetic means. So we could write this saying that 5, 7, and 9 are arithmetic means of 3 and 11. Okay, 5, 7, and 9 are arithmetic means of 3 and 11. Those are numbers in a sequence that are between 3 and 11. Right? And it can be different types of arithmetic sequences, but in this case, that's what they are. Right? The next part is the part that you've seen before. A single arithmetic mean between two numbers is called the arithmetic mean. Right? So, for instance, if I make the sequence, actually, let's do this. If I say 10 and I put 1 blank there, and then I do 22, right? The number that goes there is the arithmetic mean of 10 and 22 because we have to add something to get to that number in the middle, and then we have to add that same number to get to 22 on the end. So if you haven't figured it out yet, the arithmetic mean, that's our average, right? That's what we talk about as an average all the time. So to get the arithmetic mean, I can just find the average. I'm going to do 10 plus 22 and then divide by 2. So 10 plus 22 would be 32, and then 32 divided by 2 would give us 16. So the arithmetic mean of 10 and 22 is 16. Right? We're just kind of thinking about it in a sequence. And again, we can have more than one arithmetic mean, right? Okay, so if I want to find the arithmetic mean of 4 and 9, you can think about it like a sequence. I have 4 here. I want to place a term in the middle, and then my other term is 9, right? So basically, we're looking for what do I have to add to get to the next number, and then add the same thing to get to 9. But again, remember, if it's the arithmetic mean, you're basically just looking for the average between those two numbers. So I can do 4 plus 9 and divide by 2. That would be 13 over 2. So the arithmetic mean there is 13 halves, right? Okay, now that's if we're just finding the arithmetic mean. On the next problem, now we want to insert 4 arithmetic means between 15 and 50. So now I'm not just finding the one average of 50 and 15. I want to put 4 numbers in a sequence in between 15 and 50. Okay, so that means I'm going to start with 15, And then I want to place in 4 numbers. So 1, 2, 3, 4. And then I want to end with 50, right? Okay, so there's a couple ways you can go about this. I'm going to first do it just by using the formula that we know, but you can also kind of logically think through this. So it's up to you how you want to go about it. So basically, I need to figure out what is, because I know it's arithmetic, I need to figure out what is that common difference, right? What do I need to add each time to get these 4 terms that go in the middle? Okay, well, remember we have a formula, right? We know that it's arithmetic, so we have this formula that generates terms, and it's a sub n equals a sub 1, or the first term, plus our common difference times n minus 1, right? Okay, so if I wanted to plug in some things I know here, well, I know the first term, right? This 15, that's a sub 1. I also know this guy, this would be the 5th term, right? Or no, I'm sorry, 1, 2, 3, 4, 5, 6. That would be the 6th term that I have in this sequence. So we can use those 2 terms and plug them into that formula, which will help us find out what D is. So I'm going to make a sub n, I'm going to make that our 6th term, because that's the last term that we have. We know our first term, that's 15. And then we're going to add, I don't know the common difference, right? But now if I'm looking at the 6th term, then that means my n is 6. So I do times 6 minus 1. Okay, so then let's actually plug in the 6th term. We said the 6th term is 50. And then 15 plus 6 minus 1 is 5. That would be 5d, right? Okay, then we're going to subtract 15 from each side. So that would be 35 equals 5d. And then divide both sides by 5, we get d equals 7. So that means that our common difference up here is 7, right? So to get our next terms, we just have to add 7 every time. So 15 plus 7, let's kind of rewrite them down here. So we started with 15. If I add 7, that gives us 22. And then if I add 7 again, I get 29. If I add 7 again, I get 36. If I add 7 again, I'll get 43. And if I add 7 again, I get to 50, which is what we wanted to get up here, right? So then the means that we inserted would be 22, 29, 36, and 43. Okay, so you can use that formula to come up with what the common difference is, and then you can use that common difference to find your next 4 terms. Okay. All right, let's do this one more time. Or if you would like to, now would be a good point to pause the video. Try example 3 on your own. It's going to do the same thing. You want to insert 3 arithmetic means between 18 and 54, right? So set it up the exact same way. Plug the stuff into the formula and see if you can put those means in there. I'll kind of pause for a second if you want to pause the video and try it on your own. Okay, so if you tried it, you're back, or if you're just going to watch another example, we'll go through this one. So this time I'm starting with 18, and I want to put 3 numbers in here, right? So 1, 2, and 3, and we're going to end up with 54. Okay, so again, 18, that is my first term. 54 would be my 1, 2, 3, 4, 5th term. And it's arithmetic, we know that, so we're looking for what is our common difference, right? So we can use our arithmetic term generator, which is our a sub n equals a1 plus the common difference times n minus 1. So I'm going to use a 5 this time, because that's the last term we have. My first term is 18 plus, I don't know the common difference. And if I'm doing the 5th term, I'm going to do 5 minus 1. My 5th term is 54. And then 5 minus 1 is 4, so we get 4d. So then 54 minus 18, I'm going to move the 18 over, would give us 36 equals 4d. Divide by 4, we get d equals 9. So that means we need to add 9 each time, right? So if I started with 18 I'm going to add 9, I get 27. Add 9 again, I get 36. Add 9 again, I get 45. Add 9 again, we end up with 54, which is what we wanted. So the three means that we inserted are 27, 36, and 45. Okay. All right, so that's how we can insert means into arithmetic sequence. Okay? We can insert terms in between two numbers to make sure they all have the same common difference. All right, let's try now geometric means. This one's a little bit different. We've talked about a mean as an average, right? An arithmetic average is where you add the two numbers together and then divide by the number of numbers to get an average, right? Well, you can also find a geometric mean, right? It means the same thing. It's just a geometric sequence instead of an arithmetic. So if I make a geometric sequence, I'll make it easy. Let's start with 2, and I'm going to multiply by 2 every time. So 4, 8, 16, 32, right? That would mean that 4, 8, and 16 are geometric means of 2 and 32, right? 4, 8, and 16 are geometric means of 2 and 32. Those are the numbers that I could place in there and make a geometric sequence. Okay, and again, a single geometric mean between two numbers is called the geometric mean, right? Now, geometric mean is a little bit different because we're looking at what are we multiplying by to get the next number, right? So before we did the arithmetic mean and we found the average by adding them together and then dividing by 2. To find the geometric mean, again, that means I want to take 4 and look at what number would go there and then 9, right? Now, with a geometric average, it's a little bit different. Instead of adding and then dividing by 2 to find a geometric mean, we're going to multiply and then take the square root, right? So I'm going to do 4 times 9, and then I get 36, and I'm going to take the square root of that, which will give us 6. And technically, what did I forget? My plus or minus, right? So it could be plus or minus 6. So it could be that our geometric mean is 6, or it could be that our geometric mean is negative 6, because that common ratio could be a positive number, or that common ratio could be a negative number. So there are technically two possibilities for the geometric mean between 4 and 9. It just depends on if you know that you need the positive or the negative one, but it could be either one. Okay, so let's kind of go through a problem just like before, where we want to insert three means between two numbers, but this time we're going to insert geometric means, right? So we want to insert 3 of them. So that means this time we're going to start with 1/2 as our first term, and then I want to put in 1, 2, 3 more terms, and we want to end with 1/162, right? Okay, now this time, just like before, in order to get those 3 numbers, we need to know, because it's geometric, what is that common ratio that we have to multiply by to get those 3 terms, right? And again, just like before, we know that this is our first term, and this would be our 1, 2, 3, 4, 5th term, right? 5th in the sequence. So again, we can plug stuff into that equation or that formula to try to find our common ratio. Just remember that this time it's geometric. So our formula this time is that our AN equals our first term times the common ratio to the n minus 1 power. Okay, so this time I'm going to use A5. Our first term is 1/2. We don't know what our common ratio is. And if we're looking at the 5th term, we're going to do to the 5 minus 1. So then our 5th term we know is 1/162. And then 1/2, that would give us r to the 4th power, right? Okay, so then to solve for r, well, to get rid of that 1/2, I can multiply both sides by 2, right? So then if I reduce these, that'd be a 1 and 81. So I get 1 over 81. And then the 1/2 and the 2 would cancel out. That would equal r to the 4th power. Then to get r, we're going to take the 4th root of each side, right? So then we would get r equals, the 4th root of 81 is 3. So it'd be 1/3. Now this is an even index that we're doing, right? If it's even, that means we need a plus or minus. So our r value could be 1/3, or our r value could be negative 1/3, right? So if r is positive 1/3, then our terms would be 1/2, and then we're going to plug in our 3 terms, right? But we're going to multiply by 1/3 each time to get the next term. So 1/2 times 1/3, that would give us 1/6. Multiply by 1/3 again, that gives us 1/18. Multiply by 1/3 again, that'll give us 1 over 54. And multiply by 1/3 again, we get 1 over 162. So the 3 numbers we inserted were 1/6, 1/18, and 1/54. Okay, but then we have the other possibility if r equals negative 1/3. Well, again, we're going to start with 1/2. If I multiply by negative 1/3, I would get negative 1/6. Multiply by negative 1/3, I'm going to get positive 1/18. Multiply by negative 1/3, I get negative 1/54. And then multiply by negative 1/3, I get positive 1 over 162. So we got kind of 2 possibilities there, but our 2 possibilities would be these guys, right? So those would be our geometric means that we could insert into that sequence between 1/2 and 1/162. Okay, so arithmetic and geometric means, basically like averages, but we can put more than one of them in between 2 numbers. You just have to know whether you're inserting arithmetic or a geometric means. Okay, homework to go with these notes will be posted. Again, just a reminder, this PDF right here at the top of OneNote, this is where you can print out a blank version of the homework or of the notes, right? So if you want to print notes or homework, make sure you're clicking on that PDF to print them out. If you're doing it on your own sheet of paper, that is also completely fine. If you're still having trouble uploading things to OneNote, please make sure you let me know and I can help you out. I will see everyone in our live class, or I have already seen you in our live class, depending on when you're watching this. But keep working hard, take some breaks, get some rest, get some sunshine if you can. I will see you all soon.